Hi, I'm Jagdev. By profession, I'm a pharmacist, but I'm here to share with you very pertinent information on fatty acids, being a member of the International Society of the Study of Fatty Acids and Lipids, ISSFAL for short, ISFAL. I've been a member since 2010, and I've been attending all their conferences since then, every 2 years once, and I've met some of the best minds in the field of fatty acids. Today I will be able to share with you one aspect of fatty acids called the omega-3 index and how it is related to your health. And this is going to be a very interesting lecture on this aspect. The story started way back in 1995 when Dr. Siskovic and her colleagues from the University of Washington, Seattle did an interesting study. What she did was, instead of looking at other parameters, she looked at the levels of omega-3 in the blood samples using a gas liquid chromatography. You can measure the amount of omega-3 in your blood. She had patients who had primary cardiac arrest, 82 of them. She measured this omega-3 in the blood samples, and she then compared this with 108 controls. I will talk to you about the bilipid layer of the cells that you see on the screen later. But what she did was, once she compared, she took break up into 4 quartiles, and this is what she found. If you look at your x-axis, you see as high as 6.5 and lowest at 3.8. That's your mean red blood cell omega-3 fatty acids, the amount which is found in your blood. And she then compared this versus the odds ratio, as I said just now, divided into 4 quartiles, and she found that those patients or those people having high omega-3 in their blood had lower risk, and this risk was reduced by 90% compared to those who had very little omega-3 fatty acids in their blood. And I think this is where the whole idea of omega-3 being used as a measurement to predict heart disease started, the whole idea started. But let me go on further to something which was done newer. This is called the Physician Health Study, involving 22,000 physicians. They followed it up for 17 years. This is based on a questionnaire. From these 22,000 physicians who were followed up for 17 years, about 94 of them had sudden cardiac death, and they died. They had blood samples measured on their omega-3, and again, Dr. Christy Alberts from Harvard Medical School did a similar study. She divided this, she compared this to about 200 odd patients, and she divided these patients into 4 quartiles: quartile 1, quartile 2, quartile 3, quartile 4, which you see on the screen. And once she found that again, those patients having high omega-3 in their blood tend to have lower odds ratio risk of getting sudden cardiac death. And this is a huge study. And if you look at the figure there, it's 6.87 versus 3.58. So that's the kind of blood levels are we seeing versus omega-3 fatty acids in the blood. Now, Christy Alberts is from Harvard Medical School. And it was all very significant. Now, one of the biggest human trial ever done on omega-3 fatty acids is called the GCP trial, an effort by the Italian doctors led by Dr. Roberto Maccioli. Now, he followed up 11,000 odd patients, followed them up for people who have had heart attack within the first 3 months. They were put on either 4 arms. One was the omega-3 arm, one was the vitamin E arm, one was the omega-3 and vitamin E, and the last one was controls. Now, what is interesting about this trial is they use a very particular form of omega-3 called the omega-3 acid ethyl esters, right? Now, they followed these people up for 3.5 years, and within 3.5 years, they were able to show that the incidence of sudden cardiac death dropped by a tremendous amount of 45%. CV death dropped by 30%. the overall mortality dropped by 21%, and the non-fatal MI incidents dropped by 20%. These are all very fantastic, very good reports, and this was one of the huge study. And again, the omega-3 which was used was 1 gram, and they were using the form which is called the acid ethyl esters form. It's sudden cardiac death, and you understand that sudden cardiac death can be a major problem amongst patients all around the world. Going forward, this was reported in 2019, just last year, in the Journal of the American Heart Association. This is a meta-analysis, marine omega-3 supplementation versus heart disease, and this meta-analysis involved almost 130,000 people. And they concluded, the researchers concluded, that marine omega-3 supplementation lowers risk of myocardial infarction, CHD death, total CHD, CVD death, total CVD, even after exclusion of the very famous trial called the REDUCE-IT trial, which we will not speak about here. And the risk reduction appeared to be linearly related to the marine omega-3 fatty acids. This is a recent trial reported in a BMJ, just around the corner, just in March this year, involving another meta-analysis involving something like almost 500,000 people. And in this particular trial, they looked at the habitual fish oil supplementation versus the CVD outcomes and all-cause mortality. And all-cause mortality reduced by 13%, and dying from CHD reduced by 16%. These are all again very huge data proving that omega-3 really works. This is another trial done by a friend of mine, Dr. Robert Bloch, and reported in JACC, Heart Failure, July 2019. And you know, people who got MIs, they eventually end up with heart failures. And in this particular trial, they did give these patients omega-3 fatty acids just in the EPA form, ethyl esters form again, and they followed them up for about 13 years, and they were able to show a reduction of incident heart failure with omega-3 fatty acids, right? Involving 6,000 patients, again a very impressive data to show that just by giving EPA form of ethyl esters, we were able to reduce incident heart failure. That's Dr. Robert Bloch. In one of my visits to the conference, met him, good friend of mine. This is another. Now, very interestingly, way back in 1996, when I was doing this research on omega-3 fatty acids, I stumbled upon the work done by Dr. Leaf. He reported some studies in 1996. I read the studies, and very interesting studies, because you know why? He had a heart attack. His father had a heart attack and died. His brother had a heart attack and died. This is a Harvard Medical School professor, right? When he had his heart attack, he was 73 years old. Now, and the year was 1993. And he was inspired by this particular trial done by Dr. McLennan, Professor McLennan, whereby McLennan gave rats 4 different sets of diet. One diet with saturated fats, another diet with olive oil, another diet with sunflower seed oil, and another diet with fish oil. And he then induced ischemia using irreversible ventricular fibrillations, and then he found that the rats which was given fish oils, none of them died. Total mortality was 0, okay, compared to those who were given sunflower, olive oil, and saturated fats. And we are talking of ventricular fibrillations, we are talking of arrhythmias, and this inspired Dr. Leaf to do a trial in Harvard Medical School. He took 12 dogs. He personally told this story to me. He took 12 dogs. He induced ventricular tachyarrhythmias. He occluded the main arteries, made the dogs run on a treadmill. Basically, you're asking for trouble. You can see from the slides that the ECG readings go haywire once the treadmill stopped. Now, the same dogs, he introduced omega-3, he infused omega-3 fatty acids in this same form, ethyl esters form. He did the same thing. The dogs were occluded, made the dogs run on a treadmill, and you can see for yourself the arrhythmias were abolished, right? Now, whether to prove him right or to prove him wrong, he then infused omega-6 fatty acids in the form of soya bean oil, and the arrhythmias came back again. Now, as I was mentioning just now, all the studies that I'm trying to prove to show that it does reduce sudden cardiac death, and sudden cardiac death is actually a factor of arrhythmias. And now, Dr. Leaf from Harvard Medical School actually shows you the mechanism of action, how these arrhythmias can be abolished with omega-3 fatty acids by shunting off the excess so-called ion channels within the myocytes of your cardiac cells. So, the big question here is, now that we have got data to show that the higher the omega-3 fatty acids in your blood, the lower your risk of getting sudden cardiac death, or the lower your risk of getting cardiac events, can we not use these omega-3 fatty acids, just a measurement of these omega-3 fatty acids, to tell you whether your risk of getting a cardiac event in the future can be predicted? This was a question. So the question here is, should blood omega-3 fatty acids levels be considered as a potential risk factor for sudden cardiac death? If so, what are the levels? Now, this question was actually looked upon by Professor Dr. William Harris, professor from Stanford University, South Dakota, and he looked at this way back in 2002 when Dr. Christy Albert's data came out, which was a repeat of what Dr. Siskovic did, and that's when they came up with the idea of omega-3 index. Now, let me just explain to you what is omega-3 index. It's basically a biomarker that you can measure directly from your red blood cells. Your red blood cells have got a bilipid layer, and your bilipid layer is all basically fatty acids, right? So the question here is, how much of fatty acids must I have there to prevent me from predicting a cardiac event in the future? Now, this is a model. In this particular model, you have got three red lines there denoting 3 fatty acids, okay, and they are in omega-3 form, and the total number of fatty acids there are 64. So if I take 3 over 64, that gives me a percentage of 4.6%. That's how the omega-3 index is derived, right? And I said just now, you can measure omega-3 from your blood samples. Now, there are a couple of questions that we need to ask ourselves. Now, in this particular model, if, say for example, I've got 100 fatty acids, how many omega-3 fatty acids do I need to give me the protection? Okay, but before that, I need to ask 2 questions. If I were to take more omega-3, will this correlate to my omega-3 in my blood? Will this correlate to my omega-3 in my cardiac cells? Okay, and this question was answered by using this data. Now, in this particular trial, which was done on 28 patients, effect of fish oil supplementation on the RBC, and you can see for yourself, the longer amount of omega-3 fatty acids that I give to patients, the omega-3 or the omega-3 index rises up. So there is a direct correlation between taking either as supplementation or taking either as fish as food, and the relationship with omega-3 fatty acids in terms of omega-3 index rises up within your red blood cells and also within your atrium. Next question, how much of omega-3 do what's the level that I can reach? And you can see there's a level, a green line there, which denotes the 8%, and they found that if I don't give supplementation or if I don't give food, the levels will be very low, none per week, that's 4.3, and if I give more omega-3 as form of a food, either as supplementation or as fish, then my omega-3 goes up, and it can go up to 8 if you take 3 times per week with supplementation. So now, let me just denote something very important here. What are the levels? Now, various trials have been done. If you look at the Seattle trial, the University of Washington trial done by Siskovic, the level was about 6.5 roughly, which gave you the 90% protection. And if you look at the GCP trial, the levels was estimated at about 9 to 10%. So what they did was, and if you look at the PHS, that's the physician health study, it was about 7%. So what they have done is, they have, to give 100%, they have done a mean which is about 8%, which means, going back on that omega-3 index model, the bilipid, if you got 100 fatty acids, I just need 8 omega-3 embedded in the bilipid layer to give me the protection. That's all. 8%. What is the least protection? You are talking of something below 4%. So if you've got anything below 4%, will give you a least protection. So this is where they have come up with a desirable omega-3 index, which is 4 and below is undesirable. And if you look at the data, 8% and above is desirable. So that's how they have come up with. And if you look at the Japanese, have got very little omega fatty acids, they've got a desirable factor of about 8%. You know, the amount of fish that they take is 10 to 15 times more than the Westerners. Hence, the omega-3 naturally already have omega-3 index of more than 8. Which gives them great protection versus typical US and Westerners who have got 6 and below, even 4 and below. That is undesirable. So this is how the whole omega-3 index is being narrated. So now it's very simple. I'll give you more data first. Then, because you have to decide whether is this something that you want to do for yourself or for your patients. Now this is a trial, a meta-analysis involving 27,000 people. In 10 clinical trials. They measured omega-3 index 4, you can see the 4, red one is 4, that means omega-3 index which is 4, 6 and 8 or 8.2 there, and they measured the odds of ratio of getting a fatal CHD, so fatal heart attack. So meta-analysis omega-3 index as a predictor of risk for fatal coronary heart disease, and they were able to reduce, they can be shown there, reduce the reduction for those who have about 8%, the total reduction is about 35%. This is equivalent to any other drug which you can find outside there, and this was reported by Dr. William Harris in 2017, arteriosclerosis. Now this is another data, omega-3 index and acute coronary syndrome. This is 768 case control pairs. Again, 4%, 8%, the odds ratio of having heart disease drops by 70% in this particular trial. This was again reported way back by Dr. Robert Bloch in 2008. Right? So you see the data is very, very strong that if you have got omega-3 index of more than 8, that reduces your risk drastically versus if you have got omega-3 index of 4 and below. This is another one. Relative risk for death from any cause and the omega-3 index, the Women's Health Initiative memory study, whereby they measured the omega-3 index and they also measured the odds ratio of dying from any cause. It wasn't a heart disease study, it was dying from any cause mortality, and they were able to show that those having a percentage of 8% of omega-3, the risk of dying from any cause reduces by 31%. They're all showing an inverse relationship. This was reported in the Journal of Clinical Lipidology in 2017 by Dr. William Harris. This study was involved 6,500 patients in post-menopausal women. Right? This is another study. This is called the Framingham, not the Framingham famous study, which was started in 1948. This is the Framingham offspring study. You see the original Framingham patients, they're all probably dead and gone. These are the offspring. And in this particular trial, they were able to show taking 2,500 persons free of CHD, and they followed them up for 7.3 years, and they found that those having omega-3 index of more than 8, the risk reduction again drops by inverse relationship by about 30 to 40%. Now, if you look, there's another graph there showing cholesterols. The cholesterol level were really not predictive. So this is a very interesting case whereby the study researchers were able to show that the omega-3 index as a predictor of heart disease was much more predictive compared to your cholesterol levels. And I think this is a very important point that I would like to emphasize. Okay, here I would like to explain, giving more depth into our understanding of your cell membrane. As I mentioned just now, the cell membrane has got a bilipid layer. right? Now, the cell membrane is very important to the integrity of the cell. The cell membrane decides what goes in and what goes out of the cell. Now, and this is controlled by the lipids. Fatty acids are very, very important component of this lipid layer. Now, here there are two diagrams there. Okay, in that picture, in the second on the right hand side, the two picture there. One is a raft of the cell membrane, and the other one is a caveolin, just like a cave. It's known as caveolin. Now, EPA DHA can modify the membranes. So the higher the EPA DHA, as I say, it's not up to 8%, it can modify. How does it modify? Point number one, at the rough level, it can reduce your sphingomyelins, right? And the other one, at the caveolin levels, it is able to reduce your cholesterols. So it can modify. Let me just go even deeper than that. Okay, that's another slide that I have here. Right now, you will see three things there. Now you will see the center one, which is the ion channels. I already explained to you. The ion channels is actually is a sodium, potassium, calcium channeling which is going on at the cell membrane, and that's what gives the omega-3 the effect of the anti-arrhythmic effect. Now, side by side, you will see GPCR or GPR 120, which is actually a portion which signals the inflammation, and the omega-3 can modify that signaling effect, right? This is a G protein couple receptors. So these are basically receptors, and they also have the receptors for the insulins. And on the other side is your membrane fluidity. That means it also decides the fluidity of your membrane, and all these can be affected by your EPA and DHA within your cell membrane. And you can see nuclear factor kappa beta can be reduced. Nuclear factor kappa beta is a very strong indicator of inflammation. There's inflammasomes. Inflammasomes can also be reduced, and the whole signaling effect can be reduced, reducing overall reduction of your inflammation. And I think by now we all are beginning to understand that putting aside cholesterols, okay, the underlying cause of your heart disease is inflammation. And if we can reduce inflammation at the cell membrane level, at every cell, we are talking of myocytes now, and by embedding more omega-3 fatty acids, you are going to reduce inflammation at your endothelial layer of your arteries. Okay. Now going further, where are the effects? Right at the left corner is your adipocytes. It will be able to reduce your inflammation response at your adipocyte levels, right? And you go on the right hand side, it also reduces your triglycerides using omega-3 fatty acids. And then on your left hand side down, it has got a vasodilatory effect. That means it will actually reduce your blood pressure by about 2 to 4 millimeter mercury. And on the right hand side, you will see the anti-arrhythmic effect of omega-3 fatty acids. So this is how it affects the heart in various ways, liver, and also the arterial. Now, this only gets more interesting. The omega-3 index, how does it compare with traditional CHD risk factors? Now, Dr. Christy Alberts also not only looked at omega-3 fatty acids as a measuring the omega-3 fatty acids, she also measured many other things. She measured CRPs, she measured the homocysteines, you can see on the graph, on the slide. She measured the total cholesterols, LDLs, HDLs, total glycerides, total triglycerides, total cholesterols versus HDL as a factor or as a ratio, and last was the omega-3 fatty acids. Now from this slide, you will see that yes, CRP has got some predictive value. If you look at HDL, yes, it has got some predictive value, but look at the levels, predictive value or predictive level of the omega-3 fatty acids. They are much more predictive compared to all the other factors combined for sudden cardiac death. Now, way back when I first saw all this, when I went to Stockholm for the conference, I brought back some omega-3 kits with me, and I did it in some doctors in this country. doctors who are taking PROAS. So on your right hand side, you will see doctors taking PROAS, the omega-3 fatty acids, and on the left hand side, you'll see some the doctors who were involved. I will not mention names. Now you will see the omega-3 index there, omega-3, omega-6, omega-9. Basically, the omega-3 index, when you do the sampling, it will give you a lipid profile. This is what is known as real lipid profile. It breaks down your your blood into omega-3, omega-6, omega-9, and also saturated fats, and also trans fats. So this is what is known as real lipid profile. And if you can see there, highest to the lowest, that's me, JS. You'll see JS there, and you see JS number 5 there again, JS. What I did was, I was taking omega-3, PROAS, 3 to 4 capsules. Then what I did was, I came back, I brought back krill oil, and I took krill oil for 6 months, and within 6 months, my omega-3 index dropped. Then I realized krill oil may be a good oil, but the amount of omega-3 in the krill oil is very, very little. You need to take a lot more krill oil before your omega-3 index goes up. But this is a very good indication, basically to show you the more PROAS you take, the more the omega-3 index rises up. Okay, this is a pilot study, not reported. I did it on my own, just out of interest. Now, what I've spoken today, I've been able to show you that a lower omega-3 index is associated with a couple of diseases. Okay, point number 1, the lower the heart disease, the lower the omega-3 fatty acids, the higher the incidence of sudden cardiac death, the higher the incidence of acute coronary syndrome, the higher the incidence of death from all causes. Now, which means all we need to do is to raise our omega-3 index, and you can just measure that very simply by a single finger prick test, and then it will tell you how much of omega-3 index that you have, and we can then reduce the risk or reduction of these diseases by so much. In fact, the study is showing between at least 30% to 70%. Now, it is not only about the heart. When you take omega-3, it's also going to affect every cell membrane right from your brains to your toes, right? Hence, they are now beginning to show that the omega-3 index is also useful as a predictor for loss of cognitive functions, for dementia, for cellular aging. The more omega-3 you have in your cells, the rate of aging will be reduced, and this has been shown through telomeres. Measuring the telomeres, the faster it ages, the shorter it becomes, but omega-3 is able to reverse that. That was reported in 2010 in JAMA. Also depression, and also in dry eye syndrome. So these are and 2019, I just mentioned just now, Robert Bloch's paper on heart failure as well. So these are all interesting times, and I think more data is going to come out how omega-3 as a function within the cell, and you can measure that, and we can then reduce your risk of inflammation and hence risk on developing many other diseases, right? Now, how can you get fish or omega-3 incorporated into your cell membrane? Very simple, eat more fish, right? But when you eat the fish, make sure it's not fried. Steam is always better, and we Malaysians, we tend to fry our fish. And there is a study to prove that if you fry your fish, you're going to destroy the amount of omega-3 which is going to get into your system, and that is not going to be helpful. The other way is, of course, supplementation. And supplementation, you either take a low potency, that's the normal ones, 300 milligrams, or you take the mid potency, but I would probably prefer as a recommendation to take the high potency ones, and you must make sure that your omega-3 is in the ethyl esters form. Why? Basically because most of the landmark studies use the ethyl esters form. So that's the reason why I'm recommending. It's all evidence based, right? I know there are various other forms, people are talking about other forms, but the form which was used in all the trials was basically ethyl esters form. Now, what I did differently was, remember Dr. Alexander Leaf, I met him personally, the guy from Harvard Medical School who has passed on. So he is the one who first told me where to get my omega-3. He directed me to a company in Norway called Pronova, right? This is the same facility which gave their stocks for the GCP trial. So I went there, I saw it for myself, the place, and then I spoke to them, and I was able to procure the omega-3 from this particular facility, right? And if you look at the facilities, I went to the whole place, not a single man on the factory site. Everything is controlled, automated. Next, what I did was I met up with Professor Bros Holub. Bros Holub is one of the top 10 in the field of omega-3 fatty acids. He started a company under the University of Guelph from Ontario. The company's name is Nutrasource, where they went on to look at how to certify a good omega-3 fatty acids formula, right? And they came up with the idea of international fish oil standards, where they look at 5 standard criteria to look at, and I then passed on my product called Provas to them in 2012. By 2013, we were able to get the first reports out to show that we got the accreditation from IFOS, the International Fish Oil Standards, and ever since then, every 2 years we are getting these accreditations, and the latest batch is accredited for 2022, right? I just like to leave by giving you 3 simple take-home messages from this whole lecture that I just gave. Point number 1 is that today we have the technology to measure your lipid status of your cell membrane through a very simple device or a very simple kit, whereby it's a single finger prick test called the omega-3 index. And the omega-3 index will tell you whether you are at the safe level or desirable levels versus undesirable levels. Safe or desirable levels is 8 and above, and undesirable is 4 and below, and 4 to 6 is intermediate. So we can tell you the status not only about your heart, although this is a measure that we can tell you the risk of sudden cardiac death, and all the data is presented, but it's just not about your heart, it's about every single cell in your body, because the integrity of your cell membrane decides your cell health, right? So if I can have, out of every 100 fatty acids embedded in your cell like bilipid layer, if I can just have 8, that will give me 8% out of 100. That is my safe level. So simple, so simple. And lastly, once you know where you stand, if you're 8 and above, well done. You need to manage this very well. Just keep your status quo and keep it at 8. You can measure every 6 months or 1 year just to ensure that you are on track. Okay, but however, if you got a omega-3 index below 8, maybe 6 or 5 or even below 4, no problem. Just take more omega-3, either in the form of fish, and make sure your fish is not fried, it's steamed, okay, at least 3 times a week. And you can add on a supplementation to ensure that you're getting proper omega-3 fatty acids. I'm not going to talk to you about the omega-6, but the omega-6 can negate the effect of omega-3. So ensure your omega-6 intake is also reduced to show that it doesn't negate. Now, so these are 3 basic take-home messages I would like to give away. And with that, I'd like to thank you for your kind attention. And with this information, I'm sure you will be able to take action to do your omega-3 index, and secondly, to know where you stand and how you can manage your health better. With that, thank you.